In this lesson, we're going to look at the result of spectroscopy data that we've been talking about. And we find out that electrons are not located in circles around the nucleus of an atom, but they're located in probability shapes. We are going to be looking at S shapes and P shapes today. Let's get started with the element hydrogen. I'll put its symbol here, H. Hydrogen has one dot associated with, or one electron associated with it. But where is it located? Let's look at our graph here. This is the x-axis, this is the y-axis, and this is the z-axis, representing our three directions. And of course, those directions are in space. The nucleus is located right at the origin. Our first shape, according to our movie that we watched in class, is a sphere. This looks like a circle, but imagine it really being a sphere. So the first orbital is an S shape, or a spherical shape. We have one total electron, so I'm just going to put one electron in there somewhere. It doesn't matter where we place it. The probability of electron location is going to be in the sphere. So we're in the first energy level. It is a spherical shape. We have one location, so I'm just going to draw one line in there. And there's one electron located in there. We're going to draw an arrow up for that electron. Okay, and what that means is there's electron spin. We talked about that in class. Electron could be spinning, clockwise or counterclockwise, producing a magnetic moment. We're going to put the first one as a magnetic moment up. So that's what the arrow up represents. And then I'm going to put a 1 exponent for the S, meaning that there is one electron in that S orbital. So this is the 1s1 with one arrow up. Now what about the dot diagram? Well, there's only one dot, one electron there. So our dot diagram simply is one dot like that. You'll get the pattern as we go along. If we move on to helium, there's two total electrons for helium. Our probability shape is still a sphere. So we're in the first energy level. So it goes 1s, but now there's two electrons in there. So let me put just one there, and I'll put another one like right there. Really doesn't matter where you place them. At any given moment, the electron could be traveling anywhere. So it really doesn't matter. There's one location in space. So I'm going to put a 2. But electrons will be spinning oppositely. So there'll be one arrow up, meaning there's a magnetic moment up, and one going down. Because one, let's say this electron's spinning in this direction, this one's spinning in that direction. They'd be opposite of each other because they're electrons, and they repel each other. So then how many electrons do we have? Well, we have 2. So I'm going to put 2. And I'm pairing them because they're in the same orbital or the same location in space. Let's go on to lithium. Lithium has 3 electrons. So I'm going to put 2 in the first sphere. And that again is going to be the 1s2 state. Arrow up and arrow down. Because one will be spinning with a positive magnetic field, the other will be spinning with a negative. Now what's the next shape available for an atom? Well, it turns out it's another sphere that encompasses the first sphere, but will be larger. So let me just put one electron in there. I'll just put a dot there. So that's going to be the 2s1. I'm drawing one line on top because there's only one location in space for a sphere. And there's one electron in there. Now when I do the dot diagram, I'm only going to pay attention to the 2. I'm not going to pay attention to any 1s because we want the outer electrons only. So I see that there's one dot, so I'm going to put one dot there like that. Okay, let's continue. What about the atom beryllium? Well, beryllium, of course, has 4 electrons. So I'm going to put 2 in the first sphere. Now that's full. Okay, let's go on to the next sphere. So I'll put 2 in that one. So that's going to be the 1s2, arrow up and arrow down, and 2s2 with one line again, arrow up and then arrow down. Now when I do the dot diagram for this one, Again, I won't pay attention to any ones. I want outer electrons only. I'll pay attention to anything that has a 2 on it. I see that there's 2 electrons there, and they're together paired. So I will make them paired like this. Okay, and again, you'll get the pattern as we go on to the next atoms here. Okay, now our second sphere is full. What happens after that? Well, it turns out there are p shapes that are available after you fill the s orbitals. P shapes I like to call petals. They look like petals of flowers. Okay, I can put 2 electrons in each petal. I can put like one on this side and one on this side here, one on this side, one on that side, one on that side, one on that side. So there are 6 electrons total that you can place in there. But remember, these are just probability locations. The electron could be anywhere around in there, but we're just going to keep them opposite each other to make it simple. Okay, let's go to the atom carbon. Let's go in order. Okay. I think it'd be better if we just stay in order. Okay, so let's go to the atom of boron. Boron has 5 electrons. So then I'm going to put 1 electron and another electron in the sphere. Notice how there's overlap. Don't worry about the overlap. And I'll put another electron in the sphere, just like we did there. Okay, and then let's put 1 in one of the petal shapes. So I'm going to put 1 here. So what is this configuration? Well, we have the 1s2, and that's an arrow up, down. And then we are in the second sphere again, 1s2, and then arrow up, down. How do we represent a p orbital? Well, this happens to be the second energy level. It is a p shape, but there's 3 different p shapes. So I'm going to draw 3 locations for it. Okay, and then I'm going to put 1 arrow up like this. Why? Because we've got 1 electron in the orbital. It is spinning in a certain direction. Okay, and that represents our diagram. So when I do the dot diagram, let's see what we've got. I'm not going to pay attention to anything that's got a 1. I'll pay attention to everything that's got a 2 on it. I see that there's a 2 here and a 2 here. These 2 are paired, so I'm going to put 2 dots together like that. And I see that this one's by itself, so I'm going to put it down here. So that's the dot diagram for that one. Okay, now let's go to carbon. Okay, let's see, carbon's got a total of 6 electrons, so I'm going to put 2 in the inner sphere. Now remember, there's overlap, but don't worry about that. I'll put 2 in the second sphere. I'm going to put 1 in a petal here, but I'm not going to put it in the same petal. I'm going to put it in a different petal. So what does that look like? It'll be 1s2, arrow up, and then arrow down. A 2s2, and then arrow up, and an arrow down. Okay, and then we'll have a 2p2. I'm going to draw 3 lines for that. And then I'm going to represent this electron, arrow up. And I'm going to represent this electron, arrow up. Notice how I am not putting it in the same line. I'm going to spread these out. Okay, so how does that look when we look at the dot diagram? Well, looking at this right here, I've got a 2 here and a 2 here. I'm not going to use the ones. So I've got 2 electrons that are paired to each other. And I've got 1 electron by itself and 1 electron by itself. And that would be the dot diagram for carbon. We'll finish up in the next movie. So that's it for this one.